Star Trek is one of the places, and I know there are other shows and films where this trope is kind of made very clear, but in Star Trek you see a lot of the time this clash between people that want to do science for science sake, and the phrase that they use is pure science.
Mm-hmm.
And then you have the people that say, well, no, we just need to understand enough science to do what we need to do.
Mm-hmm.
And any more than that is just a waste, right? But you have these mathematicians, starting with the Greeks,
Mm-hmm.
as we discovered last episode, but you have people that want to understand more and more of the world, and realizing that you need math to understand the world.
3, 2, 1. Welcome to Love Machine.
Welcome to another Nerding Out with That Nerdy Catholic. I'm here with my wonderful, esteemed co-nerd, Cesar. And we are continuing our conversation about the history of math. And remember, this is a larger discussion about math and truth and reality. What is real? What is math? And so we're in the middle of this discussion of the history of math, kind of seeing how math came about in our world.
Mm-hmm.
And as we'll see in later discussions, that it's important the way I'm trying to phrase this, because as we go on, we're going to look into the question, is this something we invented or something we discovered? Every time that I've mentioned math, I've in my mind have gone back and forth, what word do I use, because I think that's an important distinction as we're talking about it. But I think that it also plays in as we're looking at the history of math, where it came from.
Exactly, and how things, and how different things were, let's say, treated from different mathematicians in different places that they cannot possibly know.
So as we discussed last episode, we looked at the early history of math, and it seemed at some points that math was created, to be used as a tool by the Egyptians and the Sumerians. But then as we looked at with the Greeks, it looked like it was something that was discovered, that they treated it like it was a truth outside of reality. So that is where we were. And today we're going on with that. But before we continue, I want to let you know that we now have That Nerdy Catholic merch. You can go over to thatnerdycatholic.com/merch to get it. We have t-shirts and mugs and stickers. And it's a great way to support the show and what we're trying to do here. And it's a great way to just show the world that you're a nerd and that you're a Catholic, and that you can live in a world where both of those things live in harmony. So today we are going to jump forward a little bit in the history of math. So where are we going first, Cesar?
So I think that when we talk about math, as you said, last episode, we stopped with the Greeks. Obviously the next historical big thing was Rome, But with Rome happened something really curious. I mean, Rome conquered Greece military, but Greece conquered Rome intellectually. So all the things that the Greeks contribute to the world were adopted in the Rome Empire, in the Republic, and afterwards the Empire. And even at that point, when you have to write something, you usually something at the intellectual level. During that period of time, you write it in Greek. So
yeah,
that
like we have the New Testament written in Greek.
Exactly.
And you look at older civilizations. When an empire conquered another empire, they brought in their culture.
Yep.
They brought in everything, their art, whatever. They brought their culture in and said, okay, this is the way we're doing it now. But if you look at, as you said, a lot of things at that time, you had Latin and Greek coexisting.
Exactly. And that is because Rome allowed each one of the let's say of the cultures that they were conquering, they allow them their own religion, and they allow them their own, you know, their own culture.
Yeah. Oh, and I would say also Rome, compared to other ancient cultures, Rome saw the value of bringing in different aspects of other cultures into itself.
Yes.
It didn't just say, this is who we are, this is how we do things, and you have to do things like us now.
Yep.
They actually saw the cultures that they were conquering, and they saw the good in them and said, well, let's they kind of cherry picked different aspects of cultures.
Exactly. And that's how we have, for example, the historians at that time, they also write it in Greek. You know, part of the Maccabees were written in Greek too, no? That part of the Bible that is between 300s and the time of Christ was written in Greek. In that way, I will say math was really influenced by Greek mathematicians, no? And we can, that's not, by no means we are saying that during the Roman Empire there were no mathematicians that we can see. There were, but let's say their contribution was less important than the Greek mathematicians. No? They kind of expand or continue on their work or apply their work, but that was it. No.
Well, and I think you can see, just comparing the way that the Greeks wrote their numbers and the way the Romans wrote their numbers. The way the Greeks wrote their numbers, you know, with their alphabets using the ones, tens, and hundreds place, versus, you know, the Romans with the. I still have a hard time when I'm trying to write out a large number in Roman numerals.
Yes,
because it's very complicated, and it's very beautiful.
Yes,
but it's not good for making quick calculations.
Exactly. To write a number, you have to do a calculation previously. You know? To write a 6, you put a 5, and the 1 afterwards. No, so those you while writing the number, you have to do a calculation, and then if you want to use that number to do a calculation, that's a little messy. Really, that's a really messy. But at one point, Rome divided in two. No, because the empire was too big, and so we have the Western Rome and the Eastern Rome. And the Eastern Rome, it's called the afterward will be called the Byzantine Empire. The Western Rome just fall down and start the Middle Ages at that time. No, and during the Middle Ages, we got, you know, that's all the culture that, you know, the Greeks and the Rome were so used to disappear. Well, no, because that's one of the big, let's say, contribution of the Catholic Church at that time. In the monastery, you know, they keep the knowledge, they keep the all the culture from that fallen Rome, and the Catholic Church and the monastery, to be more precisely, were the places that the knowledge was preserved.
Yeah.
You know?
Yeah. So we have this period of history where in Europe we have large groups of barbarians that were rising in power. They were sacking all the cities and destroying whatever they could see. And we think of that time, that's what we think of, that it was a time of disorder and time of going backwards in scientific knowledge. But as you said, we had, you know, there were monasteries that were preserving a lot of documents, a lot of writings of science and math, and just holding on to it for the time when people would appreciate it and need it again.
And not only that, but is the Catholic Church the first one that starts the schools, and in the school teaching the
universities.
Yes, afterwards the university. Although the university comes in the 10th century or 11th century, when we talk about the schools, we have to think about, you know, the 7 liberal arts, no, and that includes arithmetic, geometry, and of course humanities too, no. And that was taught by the Catholic Church, you know, in all Europe at that time. And you are right. So this is the time of the 11th century is the time of the first university, like University of Bologna in Italy, University of Oxford and Cambridge in England, University of Salamanca in Spain, and University of Padua also in Italy. So you see that the Catholic Church was the big pusher and enabler of the knowledge, let's say, no. And during the Middle Age, there was a lot of let's say a lot of advancement in arts, in literature, all guided, of course, with God and the Catholic Church. You can see the beautiful churches, the architecture there, no. But there was not so much advanced, let's say, math. But the fact that there was not such an advanced math in Europe doesn't mean that there wasn't advanced math at all. So we have to see to the other side of the world, no? What were the India and Persia at that time, which you know what we know the Arabic world right now, were doing, no? And that's how we got our first mathematician to study, which is Brahmagupta. Brahmagupta, he was an astronomer and a mathematician, and he knows because of he wants to develop the astronomy, he started to develop math as a tool to go for astronomy, no? But what we see here is the introduction, the use of the Arabic word, the Arabic number, sorry. No? The Arabic number that further down the road will be adopted in all Europe. We can see that in his book. No? So that's kind of the first the first important thing I will say. The other important thing is the introduction of the zero. No? You know, you and I are so used to 1, 2, 3, 4, 5, 6, 7, or can't 1 minus 1 equals 0. But he introduces 0 as a number, as a concept too. No? Yeah. And he started making some, let's say, descriptions or properties of 0, which is really interesting. We have the first person that is studying 0 as a concept, as a mathematical concept.
Yeah, it's hard to imagine what life was like before that, to say how do you describe nothing without saying, well, there were 0 things. And you know, there's always been an understanding that you can have nothing, but to combine that with the math that you're doing, that was a huge development.
Yes, Brahmagupta, he lived around the early 7th century, no. So just to put in place, he during that time, let's say the Byzantine Empire was in all its splendor. Rome has already gone.
Rome had fallen.
Rome has fallen. 3 centuries before that, but but the Byzantine Empire was still there. No? The next one, it's important mathematician, is Al-Khwarizmi. No, and this is one of my favorites because I remember when I was a kid, I have the Baldor books, and Algebra was my favorite one. No, and Al-Khwarizmi is mentioned in this book, no, as the father of algebra, and you know, to dig into more what was at that time, why it was considered him the father of algebra. So the book that he wrote is Al-Jabr. No? And phonetically, you can see the similarities. No? Al-Jabr, Algebra. And what the book is about is it's how do you evaluate an equation by the method of adding or subtracting or multiplying or dividing different quantities in both sides of the equation to maintain that relationship. So that concept of doing that in order to allow the unknown expression or the unknown number to be known, it's described in his book Al-Jabr. No? So that's the reason he is considered the father
Okay.
of algebra.
Interesting.
No?
And it's so interesting to see, kind of as a pull back for a second from the math, but to see the history of a word
Mm-hmm.
and how, as you said before, how everything is all connected in the world.
Mm-hmm.
You know, we pull things from here and there, and how important it is to know where they come from. I remember, you know, you think about the big news, the news agency in the Middle East, Al Jazeera,
Oh.
So that is a word
Uh-huh.
that is used a lot in the Arabic world,
Mm-hmm.
and so you have Al-Jabr,
Mm-hmm.
but then that comes to the West, and that gets transformed from Al-Jabr into Algebra,
Mm-hmm.
but it still holds that
Arabic
piece,
root. Yes.
the Arabic root.
Mm-hmm.
And so if you know the history of language, the history of words, where words came from,
mm-hmm.
you can take one word, algebra, and you can pull out so much history from that. And it's like, well, this is where this came from, and so we have to be we're thankful to the Arabic world
Mm-hmm.
and in India
Yep.
for so much of what we have now with math.
And you're right, that's a lot of and trade and how the world was shaped in that moment takes a big place, no?
Mm-hmm.
So when we talk about Al-Khwarizmi, we talk about early 9th century,
Mm-hmm.
no? Early 9th century, just prior the Crusades, because we have to the Crusades we'll say is early 11th century or something like that. But just before the Crusades, and we do have, you know, the Muslim world start to be in shape. No.
Mm-hmm.
On the other hand, the Constantine Empire, which was 2 centuries ago, was in the biggest size in the, let's say, in his maximum,
Mm-hmm.
started to be threatened through the different Eastern or Middle Asia empires of that
Mm-hmm.
time. No?
Yeah.
But nevertheless, trade was still happening there.
Yeah.
No?
Well, and for another aside, I feel like this is my day of asides, but
Yeah.
I want to just emphasize that, you know, looking at what happened in the Arabic world at that time, as you said, you know, we're about 200 years before the Crusades.
Mm-hmm.
I know that when I grew up, at least in the where I grew up in my family, and you know, the education that I got, I had a very simplistic view of history, especially thinking about something like the Crusades,
Mm-hmm.
about other cultures. And, you know, I grew up learning, like, well, you know, the Crusades had to happen because, you know, all the evil Muslims were taking over the world.
Mm-hmm.
And I was given such a simplistic view of, you know, who the Muslims and who the Arab world was.
Mm-hmm.
But as we're seeing, you know, there were people in all cultures that were desiring to know truth.
Mm-hmm.
And thinking about in the area of math, you know, I'm sure that there's a very good chance that none of them were thinking about taking over the world.
Yeah,
you know,
definitely.
You know, and just like there are in every culture, there in our culture, that, you know, there are people that are thinking about people that are different from them, and, you know, wanting to fight against them. And there are people that says, you know, I just want to know what's true.
Yeah,
right.
Exactly.
So
So let's jump into the next big mathematician here
Mm-hmm.
that we have. He's also an Indian mathematician. He is Bhaskara II. No, and Bhaskara II lived in early 12th century. In that case, no. So 12th century, long has gone. Let's say the Arabic world, the Muslim world, has expanded all around, you know, either Middle East, Africa. They have also penetrated Europe and the down part of the peninsula of Spain, and the Spanish world was reduced to the upper part of the peninsula, which they contain the Arabic introduction to Europe. So that's the Arabic world. Bhaskara was on that part. In that let's say the power of the Byzantine Empire was very diminished at this time. So this time Bhaskara II, so he came from a father and mother, a family of scholars at that time. He loved astronomy and he also loved math. But what he did is he make a book with all the knowledge from the math of his time, and this is the book that probably Leonardo de Pisa has seen this and translated into Latin for all Europe. But that is the big contribution of Bhaskara II. Of course, there are some advancement on math, but the fact that he start to hold all the knowledge and to write it into the book is the thing that allows this knowledge to be transferred to the European world at that time. So that's what we know. Math has been developing on the other side of the world, and then I already mentioned him, Leonardo de Pisa. Leonardo de Pisa, he's Italian. He is known also as Fibonacci. So he has access to this literature from the Arabic world, and he start making the first translation. And he is the one that we will have to thank him for the introduction of the Arabic number into Europe. So the 0, the 1, whatever the numbers that we know right now are using, and that, for example, is in your Mac right now. I see those numbers are because Leonardo de Pisa or Fibonacci has introduced those numbers to our world now.
Yeah, I'll just keep saying this over and over again because it's just so fascinating that the history of math is so long, and things that we take for granted, like the numbers that we use, were developed not just over time, but all over the world.
Yeah,
that this really is an international thing.
Yes,
that we have ideas from here and ideas from here, and one of the things that come to my mind is I'm a big Star Trek fan. I know that's shocking, but Star Trek is one of the places, and I know there are other shows and films where this trope is kind of made very clear. But in Star Trek, you see a lot of the time this clash between people that want to do science for science sake, and the phrase that they use is pure science. And then you have the people that say, well, no, we just need to understand enough science to do what we need to do. And any more than that is just a waste, right? But you have these mathematicians, starting with the Greeks, as we discovered last episode, but you have people that want to understand more and more of the world, and realizing that you need math to understand the world.
Yes.
So you have this deepening understanding of the structure of math and how math describes the world. You have people from all over the world sharing their ideas with each other, passing it along to the next generation and the next generation in other countries and other parts of the world. And so if it weren't for that, we wouldn't have what we have today, the understanding of math.
That is correct. And so I would like to put some context before we continue with the history of maths here. We have Leonardo da Pisa or Fibonacci, and what happened during Fibonacci. So if we see Fibonacci it's almost born kind of in the time that the first university was born. What is happening here? So the Byzantine Empire has been reduced, in constant attacks. So year by year, the size of the empire it's been reducing. So where does all this, the Byzantine Empire was also a hold of culture, not only for the Greek and the Latin culture, but also because of trade and exchange, it has been absorbing the culture from India, the Arabic world, Persia, etc. So all those thinkers, all those mathematicians, when they see their places have been conquered, they have to go to somewhere. And this is the perfect spot because at that time in Europe, the first university were starting to grow. So we have a migration of thinkers, a migration of people of science and people of math going from Asia to Europe. And coincidentally, you will see, Italy is one of the first universities that we have. We mentioned University of Bologna and University of Padua there, and that's in the trade of the Mediterranean trade. The other one we mentioned is Salamanca University, and that's Spain. And why is that? You have to think about the Arabic world penetrating the south of Spain, and then during hundreds and hundreds of years, Spain has been fighting to recover back the peninsula. But that were not only battles, that were also commerce, exchange of ideas, exchange of knowledge. And there you go, you see University of Salamanca there, and two universities more, the first two, Oxford and Cambridge in England. So that's nice. You can see how the words evolve and the knowledge is being transferred from one place to another to develop that. And we are jumping right now to the kind of the end of the Middle Ages. We got Niccolo Tartaglia. Niccolo Tartaglia was I'm sorry. Before Niccolo Tartaglia, I will talk about Escipione del Ferro because he's an Italian mathematician too. He works at a university. He's a professor there, and also he's the first person to be known to solve the cubic equation.
Okay.
The way that they are granted for the financial department is that they demonstrate the knowledge. And how do they demonstrate the knowledge? At that time, there was these mathematical challenges among mathematicians. So one mathematician poses a problem to another, and the other is challenged to solve it, and then this other mathematician poses another problem to the first one until somebody loses.
Yeah.
Right?
It's the ancient version of the rap battle. Whenever I think about these challenges, that's what I have in mind. I remember watching them years ago, the movie 8 Mile.
Yeah.
And you have this, these two rappers on the stage doing this, back and forth rap battle. I can't get that image out of my mind. I would love to see someone do a rap battle version of some of these, these back and forth between these mathematicians.
Yes, that would be very interesting. In that case, what happened is that although the knowledge was shared because there was in a university, the top of the head knowledge, the age of the knowledge in every, I would say in this case in math, the mathematicians preserved that knowledge for themselves because that was their way to gain these battles, ergo to gain fundings for their departments, right? So that's not precisely a good thing if you want to spread the knowledge, but at the end, no secret kept hidden. No? What happened with Scipione del Ferro is he died, and his son-in-law was in contact with Niccolo Cardano, which is another mathematician who lived 50 years later, and Niccolo Cardano had the opportunity to talk with his son-in-law, and his son-in-law, when Scipione del Ferro died, he discovered the diary, and he discovered how he solved the cubic equation. No? At the same time, Niccolo Tartaglia, another Italian mathematician, was discovered the third-degree formula, or the equation for solving third degrees, and then was this battle again among of them too. No? So, but taking a little of history, this is an important thing, because to both of them, they are attached. The history claims that the three of them are the discoverer of the third equation. Tartaglia and Cardano are the ones that discovered also the fourth-degree algebraic equations too, the formula for solving that. And we mentioned that in the Arabic world, we were looking at the mathematicians also being astronomers. In the case of Niccolo Tartaglia and Cardano, they were also, I would say, the starting of the mechanical engineering. And just to let you a little peek here, Niccolo Cardano is the inventor of the Cardan shaft that we are using right now in automobile. Up to this moment.
Wow.
And we are talking of somebody that lived in 1400 something.
And what does that shaft do?
So that is the Cardan shaft is the one that is able to convert the movement of the motor into the wheels, but in a way that it can vary the angle. And continue to that of that movement.
Wow.
So they made so many things. But that's the one that is being preserved and using until today.
We have this idea of, I think, especially now in the modern world, that things just naturally keep getting better and better.
Yeah.
And that's not necessarily true. Sometimes things go backwards. But we do have this, we say that because there is this pattern of discovery and invention and being able to pass these ideas and creations on to the next generation, so that we can learn from those that come before us and do our best to make things better.
And talking about ideas that passes to the next generation, we are saying that these mathematicians were solving cubic and quartic equations. One of the things that the historians imply for those is that they were acknowledging that the imaginary numbers exist. So they are the first
ones to realize that
there's something like imaginary numbers, because of the square root of a negative number has to be done, or has to happen in those equations. They have to happen in the equations of second degree equations. But remember that it's not until we have a true algebra that we can abstract that. And that's why not looking at a necessary real number to have this abstraction. So that happens in the time of Cardano and Tartaglia.
Which is amazing to think about the world that they lived in, that they could come up with this idea of an imaginary number, because it doesn't the world that you see around you, you don't see anything that needs an imaginary number.
you cannot have an imaginary credit card line.
Right. Yes, sir. I'm sorry, I can't pay you back because that number that I owe is imaginary. Right. I wish I could say that. And we know now, with the advancements in especially in astronomy and physics, that there is a place for the application of imaginary numbers.
Exactly.
But here it is, hundreds of years before any of those ideas or things were discovered, and we have this discovery of an imaginary number before it could even be applied to the real world.
And that's the beauty of math. You don't have to necessarily, when you are looking at math, discovering things in math, you don't have to necessarily get them a use for. You can study math per se, which is something nice. By the ending of the Middle Age and starting the let's say the next stage, the Renaissance is happening right now, and we got Francois Viet. He lives in the 16th century, let's say, and his big contribution to math. He's a French mathematician. His big contribution to math is that he uses numbers not for the unknown letters, not for the unknown numbers, but for the constant of the of an equation. For example, instead of in a case, instead of having an equation like say x squared plus 3x plus 2 equals 0, he started to use ax squared plus bx plus c equals 0. So this gives him one more level of abstraction. And history is if you read the history of this mathematician, he was known that to be a very clever mathematician, there was no problem that was presented to him that he cannot solve at his time, which is something remarkable to be honest. There might be a problem, but maybe it's not recorded. But the fact that he started to use letters to replace the constant part of the algebraic equation helped him a lot in this another level of abstraction to derive formulas in order to be applicable to any situation.
Right. To be able to say, you can now take this equation, use it here and here and here. You don't have to reinvent it every single time.
And not only that, because the application of that of the formulas can be translated into geometry, can be translated into physics for the physics formula equations, can be translated into the other round, which
astronomy.
Which is a big contribution from these mathematicians. The last mathematician that I would like to talk about in this era, although he doesn't necessarily belong to the Middle Age because he was born in 1550, but he makes a lot of contribution to logarithms, is John Napier. So logarithm simplifies your life. Whenever you have to multiply two numbers with logarithm, you just add them up. Whenever you have to elevate a number to the power of another number, in logarithm you just multiply both numbers. It really simplifies your life, and that is a big help, for example, in astronomy, where distances are long and you have to make big calculations, multiply numbers there. A precise table of logarithms, remember, they don't have calculators. So they have to do everything manually. So you instead of elevating to the power, you just can have a logarithm tables and helps yourself, with a very big deal there. But he's the one that brings that logarithms to math.
Wow.
That's really big contribution here.
It's really neat to look at how one of the things, looking back at all these mathematicians, I think about this phrase, Renaissance man. And we use that phrase tied to the Renaissance because that's what we think of these men in the Renaissance, that they did everything. They were engineers, astronomers, mathematicians, musicians. But that type of person well precedes the Renaissance. You know, we have these people all over the world throughout history. They were doing everything, and they were doing it because they wanted to understand the world.
Yes,
they wanted to understand truth. And I think that's the one thing we keep coming back to, is that and everything that we're looking at in the history of math is this pursuit of truth.
The other thing that I would like to highlight here is that, you know, sometimes, and in many history books, when we talk about the Middle Age, we talk about the Dark Age. And was the Dark Age because the Catholic Church wasn't, you know, forbidden math and forbidden science, and was a stagnation of that. And that's not true. You know what I mean? It is because of the Catholic Church that the knowledge was preserved. Because of the Catholic Church that, you know, we have the scholastic and the 7 liberal arts first and schools. Is it because of the Catholic Church that the first universities were founded in Europe? No, and imagine, for example, and that makes, you know, Europe the perfect place for this when the Byzantine Empire was falling, and, you know, all the thinkers and the mathematicians from the empire were looking to a place to go to continue their knowledge. They find a Europe ready for that because of the Catholic Church, not in spite of.
Right,
no?
right. Yeah, this trope of religion versus science.
Yes.
The Catholic Church versus the scientist.
Yes.
You know, and a little teaser for our next episode. You know, what everyone goes to is, what about Galileo?
Yeah.
And we're going to talk about that next time.
Yes.
But yeah, we have this image of there's this stalwart scientist who just wants to understand truth, and there's the Catholic Church that wants to suppress the scientific truth because it just wants to spread its religion.
Yes.
Religion versus science is a very very strong idea that many people believe today, but it's just not true.
Exactly. If the, you know, science is the way we describe the universe right now, no?
Yeah.
And it doesn't belong to the category of religion, which is the truth revealed by God, no? And those coexist perfectly if both, you know, if a true scientific is pursuing the truth per self.
Right.
No.
Well, and that's not to say that there aren't people that are very, you know, I would use the word fundamentalist in their religion, that are very against science. There are people out there that think that, well, if I'm going to be true to my religion, then I have to reject all of this science. You know, just look at all the people that talk about the Earth still being flat.
Yeah, and that's also hopefully we are going to talk about this, because that's a misinterpretation of what the scriptures told us. No, and that's a big misinterpretation of what does the scripture says and what does it not say.
What does it not say?
Yes, it is
and
really
how
important.
And how do you interpret? Are you going to interpret the Bible as scientific literature or religious literature? And yeah, so just so you know, like, I mean, that's why we're doing this show, is because you know, we are happy, faithful Catholics. But we're big nerds. We love math. We love science, and there is no conflict.
Yes.
You know, if it's true, it's true. And as you used a great term there, that I think is important. Scripture is revealed truth.
Yes.
And so there is truth that has been revealed to us by God. But God also created the universe. God created the planets. Everything that is, God created.
Mm-hmm.
And whatever we discover through science, we're discovering something that God created. And thinking about, you said the universe, we've talked a lot about the universities today. Why did the church create these universities? Well, it's because the people in the church said, we need to understand everything that's true.
Mm-hmm.
And the sciences, you look at so many scientists and we're going to find out more about a lot of these scientists as we're going, next episode. But a lot of them are priests.
Yep.
Or religious.
Yes.
You talk about the monasteries that preserved a lot of this ancient knowledge that we wouldn't have if it weren't for them. It would have been destroyed.
Yes.
They preserved it because they wanted to preserve truth. And it wasn't just the religious revealed truth of God, but it was all truth that we've discovered, because and you'll see you see it in the intro of the show. All truth is God's truth.
Yes, completely agree with that.
Yeah. So give us a little teaser about where we're going next time as we wrap up.
Definitely, we are going to see Galileo Galilei and what is the most influential mathematicians after him that helped shape the view of our world right now.
Yeah, we're going to be looking into the Renaissance and that time period. But once again, thank you, Cesar, for this great look into the history.
For inviting me here.
Yeah. And thank you for joining us. I want to remind you that we have some new merch, and you'll see it on our bodies next episode. But if you would like to, I'm going to show you some images right here, but if you would like to order some of this merch for yourself, t-shirts, mugs, you can head over to thatnerdycatholic.com/merch. And please share this episode with all of your friends. Subscribe to the channel, or if you're watching this on Facebook, like the page. Please share your comments. Cesar and I are people. We're humans, and it's possible we made some mistakes in this episode. If you have any questions or any corrections, let us know in the comments, and be part of this conversation as well. This is not just us sharing all of our knowledge because we know everything, because we know we don't. We want to be part of a larger conversation. So please leave your comments, like the video, and subscribe, and we will see you again in the next episode.
See you in next episode.
Thank you, sir.
Thank you, my friend.
System shut down.